Hey guys, welcome back to the channel. Today I want to do a little video on the electronics for the mini CNC router. So what we got here, we have an Arduino. It's a little CNC shield. These little things are really awesome. But for the price, you really can't beat them. And we also have a brushless DC motor with a electronic speed controller and a little limit switch and just basic power supply. I want to talk about the Arduino and the CNC shield. To me, I just think it's amazing that these little pieces of hardware here, I mean, you can stack them up, put some firmware on it, and you have a little CNC controller that can literally fit in your hand. I'm not going to go into a whole big thing about it, but the basic gist of it is you hook it up via USB to your computer. You have a software on there such as Universal G-Code Sender, or I think there's Gerbil Panel. There's a bunch of different ones. And from there, you can sit there and give it commands, load programs in, all that stuff. I mean, it's pretty cool. So, we got him. The last video, I actually am going to have two of these in this mini CNC router. And the reason behind that is I really like the idea of being able to control my spindle speed through the Gerbil software. In my case right now, I'm just using Universal G-Code Sender, and through there you can give it a command. I think it's M50 and then S200 would be a spindle speed of, let's say, 200 RPM. And I really like that idea as opposed to having, something where I turn a knob to turn it on and adjust the speed. So, little CNC shield. These little things are awesome. For the price, I got this one from ZYL Tech. It came with little CNC shield. It came with a generic Arduino, limit switches, cable, and for the price, I mean, you really can't beat it. What I really like about these guys is, you have 3 axes. It actually has this 4 spot here, and what this is for is if you have to slave an axis. So for instance, if you have like a larger, say a moving gantry CNC router or something, and you need 2 stepper motors on each side, you can slave them for, both on X. So it will drive both of them at the same time, same speed, all that. And that's really cool. But what I really like about these, just one, for the price, but two, these things actually have a good bit of functionality. You can wire in an e-stop. It shows on here abort, hold, resume, spindle enable, spindle direction, coolant enable, and there's a bunch of stuff on here actually. But if you are sort of wondering what you should use for maybe like a first CNC project, I would definitely look at one of these. Basically, how you go about doing this is you will load the Gerbil firmware on your Arduino. When I did it, it went pretty smoothly. I mean, I had a few little issues, but it wasn't too bad. And then this guy, he just plugs right on him through these little pins right here. They sort of match up with the ones that are on here. And once you put them on here, through the Gerbil firmware, whenever you command, X, G0, whatever, it's already it all works together, and it's really nice. Limit switches, these are obviously going to go on the machine. I haven't had a chance to put them on yet. So if anyone not familiar with Gerbil, it's actually a really cool, it's basically a firmware, but it sort of has its own whole community with it. And people go, they put in a lot of work, to get this stuff working. And it's really awesome that we live in a day and age where there's stuff like this. I mean, altogether, there's probably $100 sitting here, and you have that much technology and that much capability for that low of a price. I mean, that's amazing to me. But the other thing I want to talk about, and I guess more importantly, is the brushless DC motor. So I did a little bit of research on these before I went and got one. And where I messed up is these, you have two different types. There is a in-runner, which is this type, where sort of the outside of the motor is stationary and just the shaft spins. And then you have an outrunner that the shaft is coupled to the outside and the outside actually spins, and there's like a little mounting bracket at the bottom where your wires and your coil, all that stuff is stationary, but the outside with the magnets and the shaft all spin as one. For RC cars, the in-runner type. The outrunner types are mostly used for planes, like RC planes from what I understand. Well, with that, you know, a plane typically, when you have a propeller, it's only spinning in one direction, right? You know, planes don't like go up in the air and then go in reverse. So this one, however, I can't say all of the in-runners, but I know this one in particular, it has forward and reverse and a neutral position, which is sort of right in the center. And I'll talk a little bit more about that and why that's sort of important with these. Now these guys, you can't just hook them up and expect them to work. You need some way of controlling these wires right here. The way you do that is with an Arduino. With these, you use a 5-volt pulse width modulated signal out of the Arduino and you give it a ground. That's all it takes. There's actually 3 wires. You only use 2 when you do it for this specific application. So the pulse width modulation on these, basically how this works is it uses between 0 to 2 milliseconds is the sort of range that the Arduino will put out to control this little electronic speed controller. Why I'm bringing this up is because this whole forward reverse situation, typically if I was to use an outrunner, let's say 0 is 0 RPM, but 2 millisecond pulse width modulation would be full RPM. And then let's say 1 millisecond or 1.5 is sort of in the center of the range, like half speed we'll say. Well, for this guy, that half speed is actually 0. Okay, that's like spindle off, 0 RPM. When you drop it down closer to 0, it throws it in reverse. And for the longest time, I kept on messing with this, and you know, I was watching. I mean, from him, I was saying, hey, go on, let's say 300 RPM. In my case, we'll just say that was half speed. And whenever I was doing that, this thing was, you know, spinning. But when I would command it to 0, it would still spin, and it would spin faster. And it was really confusing me until I discovered that. It wasn't until I actually put a piece of tape on it and I saw that it was spinning, you know, the one direction when I commanded it on, but when I commanded it off, it was spinning in reverse. So these little brushless DC motors, if any of yous ain't familiar with these or anything, basically when it comes down to it, this is just a little 3-phase motor. The way I like to think of it, just because I like to keep things simple, it's a little 3-phase motor with a little VFD. Power goes in, depending on how much voltage you put into it, is how much basically max RPM you can achieve out of this motor. This one in particular, you can't go over 12 volts. Some signal wires that all you need is a ground and a 5-volt pulse width modulated signal, an Arduino, and you're controlling this guy. So him sends a signal to a second Arduino, which in return controls this. It's sort of it's a little bit of work to get it all functioning properly, but once you do, it's just awesome. Alright, so with that guys, if you like my video, again, you know, give me a like, subscribe. If you have any questions or, you know, anything in particular, like I said, I'm not an expert on this stuff. This is just, I'm sort of learning as I go, and, you know, I do research and I make mistakes just like everyone else, but, you know, for what it is and the price of the stuff, if you're building a small project, you know, like I am, you really can't go wrong with this or this. Like I said, I would definitely do an Outrunner brushless DC motor, but that's about it for this video, and thanks for watching.